Right, this is where we left. We have 5 message types in OSPF. I can show each type using Wireshark by sniffing the packet. Type 1 message type is known as hello packet. This packet is very important to discover the neighbor, and this hello packet is sent every 10 seconds. So it not only discovers the neighbor, it also maintains the OSPF neighbor adjacency. Yeah, it maintains the neighbor adjacency. Right? Fine. Next is DBD, database description. This is sent only to the neighbors which is already established. This is the one which is carrying the LSDB of one router to another. DBD carries LSDB, link state database. What does DBD stands for? Database description. Now, this is not sent before neighbor, forming neighbor. After forming neighbor, only to the neighbor, established neighbor, only to the unicast address. Because you know the neighbor, you can send the packet to that particular neighbor address. So that is how, the DBDs are sent only to the neighbor, which is already established. Now this DBD is the one very important to make our database, to build our database. My router knows about another router's route information. Likewise, my route information will be known by my neighbor router through DBD. Link state request LSR is sent whenever there is a query. Whenever there is a query, whenever a router wants to know more details about a particular destination, LSR will come into picture. You see, LSR, link state request, is only sent to the neighbor querying for some missing link state advertisement, querying for some more clarification on a particular link state, particular destination. Destinations are here link state, no? Link state. So these link state destinations, unknown destinations, link state, if it is not clear, you see, type 2 is not an LSDB, it's just a DBD. DBD is a summary of LSDB. So definitely the receiving router will have a query. Let me tell you in a simple way. If I tell something to you in a detailed way, you won't have question. But if I send something to you in a summary way, you will have some question, isn't it? Because I'm not giving you detail, I'm giving you summary. Whenever I give you summary, which is called DBD, whenever a router gives DBD to other router, the other router will have LSR. It will send link state request asking the doubts. And the router which is receiving the LSR will respond by LSU, link state update. And then acknowledgement is sent whenever a DBD is received, Acknowledgement is sent whenever LSR is received. Acknowledgement is sent whenever LSU is received. We call this LS ACK, link state ACK. All right, we do have some scenario here. You see, I can see here two type of scenarios. No, I can see three type of scenarios. One is Ethernet. This is Ethernet. You see, there's a switch in between. Only then you can connect more routers. And here in between, I have a frame relay, a very old technology. And then we have a WAN connection. So what do you understand from this? This is inside one building. It's an Ethernet, a LAN within a building. This is, though it is one area, but it is not within a building. You see, there's a frame relay to connect a remote router. So this may be Chennai, but this may be maybe Japan. But you see, they are in same area. How is Chennai router connecting Japan? Frame relay. Frame relay is a non-broadcast multi-access environment. What do we understand from here? We understand that OSPF can fit in EIGRP, a LAN. OSPF can fit in a WAN. OSPF can fit in non-broadcast multi-access. See, we may understand this frame relay thing. What is WAN then? You see, you have an MPLS tunnel connecting Chennai and Germany. We here understand that OSPF can support any of this environment. An Ethernet environment, a frame relay environment, a WAN environment. You have an MPLS tunnel, and this is a big service provider in between to connect Chennai and Germany, and you have a layer 3 VPN. That's what WAN connection. Now OSPF can run inside. OSPF can run inside the tunnel, form neighbor with Germany router. OSPF can form neighbor over the frame relay PVC, permanent virtual circuit, and form neighbor. All right, the basic configuration, OSPF is very simple. You can configure OSPF by going under interface, which is not shown here. You can also configure the common method, going to the global mode and say router OSPF, process ID, network, wildcard mask. You know what it means? You know what this means? This means that after 0, 3 numbers. After 0, 3 numbers. You want to run OSPF. 12.1, 12.2, 12.3. You see this router 2. Where is this router 2? Yeah. You want to run this 12.1, 12.2, 12.3. You see slash 30? 30 means what? You have 3 bits, right? 12.1, 12.2, 12.3. So That is what it means. What does this means? This means that 2.1 to 2.255. That is what you see here, 0/24. Now we put that in area. Similarly, you have router 3. It is here /30 and /3/3.0/24. Okay, now to enable the OSPF process on a router, we need to put the process ID. That is mandatory. And this process ID can be different number in different router. Different number in different router. Process ID can be different number in different router. See, the process ID between the neighbor do not need to match for the routers to establish their OSPF adjustments. They don't need to match. All right. Area ID should match. Wildcard mask only we should use. We cannot use subnet mask. See, if you want to use normal subnet mask in OSPF, then you need to work in Cisco ASA firewall. You need to work on Cisco ASA firewall. ASA firewall, you know, OSPF configuration supports subnet mask. See, in OSPF on ASA firewall, you can write subnet mask. There is no need for wildcard mask. But if you will do it on a router, you need to write wildcard mask. Right? To establish full adjacency, two neighbor must be asked. See, if two routers need to form neighbor, they should be in same area. All right. So area is with respect to interface. Any individual interface can be attached to single area. Say, for example, this picture. These two routers form neighbor. It is because this interface, both are in area 2. And this is forming neighbor with this because these two are in same area, area 0. So area is per interface configuration. It's not global. It is not global. You see, the router ID can be manually configured by using this command. If router ID is already there, when you give a new router ID, it accepts your configuration, but to take effect, you have to reset the OSPF by clearing the OSPF process. We type clear IP OSPF process. This is to reset the OSPF process. Now, when you do the router ID configuration right in the beginning, you don't need this command. This command is needed only if someone has already given a router ID or if OSPF has already picked. If OSPF has already picked the highest IP address from the loopback interface or highest IP address from the non-loopback interface, only in that case we have to reset. So this is the sequence. If you give router ID, it won't go to the loopback interface. But if you don't give router ID, it will take the biggest IP address from the loopback interface. First preference is for the manual configuration. Second preference is for the loopback interface. If you have many loopback interface, in that highest IPv4 address is what it is going to take. Thirdly, if there is no loopback interface also, no, you did not configure, you don't have loopback interface, then it is going to take the highest IP address from any other interface other than loopback. The other interface can be Ethernet, it can be fast Ethernet, it can be fiber, it can be gig Ethernet or 10 gig, whatever it can be. it will take the IP address from that interface. Again, this is just an ID. Even if you don't run OSPF in that interface, it will be used as a router ID. Even though you don't advertise, even though you don't run OSPF, even though the LSA is not generated for that interface, it is just an ID. So if you have at least one interface, it can be loopback or physical. If you have only one interface upstate, then it will be taken as the router. Now, if there is no way of picking a router ID, and you also did not configure router ID, then it will show you a message, an error message saying OSPF process does not start because you don't have the router ID. Do you want to see this? Okay, so next, let's go next. So, okay, so OSPF routing process can be cleared manually by configuring. When you configure the router ID to take effect, you have to clear by putting this command. Okay, this we have just finished talking about. This is how we can verify whether the router ID that you configured is active or not. All the time when you configure it, will take the router ID that you configure. But to check whether it is been actively in use or not, you have to put this command show IP protocol or show IP OSPF. Any one command. You can also type what? Show IP OSPF. Right at the very first line here, you will see router ID. Neighbors are identified not with their exit interface address, but with their router ID. Okay. So this is the router ID of the neighbor. The default priority is 1 for Ethernet. You see at last Ethernet 0/0 interface. In that same line, last you see interface is Ethernet. So if it is Ethernet, the priority is 1. If it is serial link, the priority is 0. All right, this priority is important to elect a DR and BDR. The one with the highest priority only becomes a DR or BDR. But if the priority is a tie, then it is going to compare the router ID to decide on a DR or BDR. Next is the state. It shows whether it is full state or a two-way state. It shows the state, the condition. The dead timer is 40 seconds. The dead timer is 40 seconds. It should not go like this. I think someone has increased the timer. The timer should match with the neighbor. The dead timer cannot be 1 minute and all. It should be 40 seconds. So someone has increased the timer in router 1. No, sorry, router 2. Maybe this is because of they are connecting to frame relay. You see, R2 is connecting via serial 0. I think it's frame relay. Frame relay, you see, R2 is connecting to serial. In frame relay, the timer is 30 seconds is the hello, and 4 times 120 seconds is the dead timer. 120 means how many minutes? 2 minutes, right? 2 minutes. That is why you saw there 1 minute 57 seconds. Dead timer is 2 minutes. It is only for frame relay, the non-broadcast environment. On non-broadcast environment, when you run OSPF, the timer is not 10 and 40. The timer is 30 and 120 in NBMA network. Example, frame relay. Whereas in Ethernet, the timer is 10 and 40. Is there any question on this? Okay, next. After the timer is address is the source address of the packet from the neighbor. The neighbor router is sending a packet. The packet has got a source IP address. That source IP address is the address of the neighbor plus the interface. The local interface via which the hello packet has been received. Neighborship has been established. All right, this is the command equal to the previous command. Listen, this is show IP OSPF neighbor. This is show IP OSPF interface. If you type brief, it will be more good than this one. When you type this command, see they themselves have omitted some because it will be too many information. I told you router 2 is connected to frame relay. That is why you have non-broadcast. This is what we call as NBMA. In NBMA, the timer is not 10. The timer is 30. Hello timer is 30. Now, what do we understand from this routing table? We see that only this network is learned from the same area. Router 5 and the network of this area is same. The area of that network is same. All others are coming from other area. So instead of typing show IP route, you can say show IP route OSPF to get only the OSPF routes. This command, not many people use it, but you can try using it. Show IP OSPF route, not route OSPF. Listen, this is different from this command. This is show IP route. It's normal routing table from which you filter only the OSPF routes. This is not that. This is not a normal routing table. This is OSPF learned routes. See how beautifully it shows. It shows that this router ID is this, process ID is this, and then it has got a member with area 0, and these are the networks, and you have other area connected, and these are the networks. But when we do the lab, we should definitely see this command show IP route, show IP OSPF route. Remind me. Okay, the 7 stages. Hope you remember this, which we learned on the other day. We have initially down state between 2 routers, and then one router initiates by saying hello. The other router receives it. But the other router still has not sent its own router's hello. That's the place where we call it as init state, initialization state. Like one has sent hello, other has learned about that one, but the other has not sent hello. Next is the two-way state, is where the second router also says the hello and the first router learns the second router. Listen, second router already learned first router. Now the first router learns the second router. We call this two-way state. Extract state is the place where they will reside, who will exchange For that decision, there is a master slave elected. If it is serial link, there will be one router with a higher router ID elected as a master. The other router with the lower router ID is elected as a slave. So now master is the one which is going to exchange. So the decision of who will start the exchange is made in this place called X-start state. Exchange state is the place where the DBD is exchanged. This is type 2 messaging, right? Hello packet is type 1. You remember, that is how we started today's class. Message types in OSPF. This is type 1. Type 2 is sent only to the neighbor. And this DBD is not a detailed one. It's a summary of LSDB. It's only a summary. So there may be some queries for the neighbor. So neighbor is requesting for full content of some missing LSA, which is called as LSR, link state request, which is type 3. For that LSR, a reply will be sent, which is LSU. That is type 4. And these two, LSR and LSU, is what called as loading state. Once there is no more LSR needed, when there is no more doubt, which means they are fully synchronized. The neighbors are completely synchronized. They have full adjacency. Right, these are the 7 adjacency states. This is how the OSPF adjacency get established. Now this shows why there is need for a DIR and BDR. It is to optimize the OSPF adjacency behavior. Meaning, if every router forms full adjacency with all other router, then there will be a duplication of update. Everyone talking to everyone will cause duplicate. For example, if this is sending an update, if all will receive it, after which all will forward it, then there will be duplication of update and it will cause loop. To prevent that, there is a router called designated router elected, so that all will send. For example, if this router has got some link change, it will send it to DR and DR will send it to others. To send to DR, it will use 224.0.0.6 and DR will use 224.0.0.5 to send it. Right? So this is going to really help OSPF to have a loop-free, classless routing. Right? So the DR-BDR is important. That is helping to avoid loop. Now the full mesh is only formed with DR and BDR. Between the two other routers, there will be only two-way state. So whenever we have this multi-access, meaning LAN, more than one router as a neighbor, we call it as multi-access segment. Definitely there is going to be a DR-BDR. That is good, so that there will not be duplication of update. See what router will do. When it receives an update, it takes it, synchronizes its database and forwards it to other neighbors. That's the problem. It will immediately forward to other neighbors, but the other neighbors have already received it. So that will become the duplication. To avoid this, only we have DR and BDR. Only with the DR and BDR, there will be full sync, there will be full state. With all DR other members, there will be only two-way state. Right? That is what all these things fail experience. And in case if DR fails, the BDR will become DR automatically and there will be a new BDR elected based on the priority. And if the priority is a type, then it is going to be based on the router ID. Is there any questions so far? Okay. I know these are all very easy stuff. We have seen this so many times. Okay. So when we see this table, what we understand here, I think I have even designed a topology to make you understand this. You remember? We designed a topology. We did this in your laptop. Okay. So DR BDR election process, as I said, only with the DR and BDR there will be full adjacency. With all other neighbors, there will be only two-way state, right? And it is the router priority or the highest priority or the highest router ID. The story we have just spoken. And about these two multicast address. DR will be listening to 224.0.0.6. So non-DR routers, which we call as DR other routers, they will be sending traffic to 224.0. They will be sending the updates, not traffic, updates to 224.0.0.6, which takes the update to the DR and BDR alone. And DR will use 224.0.0.5 to notify the update to non-DR routers, which is called as DR other routers. Okay. And between the DR other routers we see here in the last paragraph, there will be only two-way state. Only with the DR and BDR, the DR others will have full state and two-way state between the DR other routers. Now we can set the priority any number between 0 to 255. The default is 1. And if you wish to make a router a DR, you have to do this configuring priority on the interface right in the beginning. Once the DR and BDR is elected, change in priority will not make any difference. You need to reset OSPF to take effect. Because OSPF DR BDR election is non-preemptive. What is non-preemptive? Once the DR is elected, other router cannot become a DR. They have to wait for their turn. This is the command to set priority. We go under the interface and say IP OSPF priority, and then we say the number. Right. And if you want to take effect, you have to reset the OSPF process so that this router can become a DR. Show IP OSPF interface Ethernet 0/1. It shows that this is an interface where router ID is 1111, IP address is this, and it is connected to the Ethernet, so it is broadcast type. It also shows who is DR. You see, router 1 is a DR because the priority was set to 100. What is the default priority? 1. Because the priority is set to 100, and you have also cleared the OSPF process in the previous page. Router 1 has become a DR, and router 5 is a BDR. Wow. So we are getting into something new called OSPF in an NBMA, non-broadcast multi-access environment. This is where frame relay comes. What is PVC? Private virtual circuit, which is frame relay.